Hey again, it's Mr. Lum, and today we're going to be doing some more naming of ionic compounds. So a quick review on some of the naming that we've already done. So here's an ionic compound. We have magnesium oxide right here. Now magnesium oxide is ionic because it's made up of a metal and a nonmetal. Let's write the formula for magnesium oxide. So what we do is we find magnesium on our periodic table and oxygen, or oxide. And we can write it like this. Mg2 plus and O2 minus. Now last time what we learned is that you can simply go MgO, and if you cross it, you'll get the right answer, making Mg2 O2. Now, the true correct answer for this is making the charge 0. And if you have 1 Mg2 plus, the charge is positive 2. And if you have 1 O2 minus, the charge is minus 2. You only need 1 Mg and 1 O to have a net charge of 0. So the true answer should be just MgO. You can still use this method. However, after you come up with something like Mg2O2, what you should do is you should find a common denominator. A common denominator like 2. And so what your answer should then become is Mg1O1. Since we don't write ones, we just write MgO, or magnesium oxide. Now in today's lesson, we're going to be looking at multivalent elements. A multivalent element is an element that can make more than one type of ion. So here's a section of the periodic table. What we can see is that some of these elements are multivalent. For example, here is titanium. Titanium can make two different types of ions. It can make a 4+ ion, and it can also make a 3+ ion. It can make two different ions. Some of them can make more than two, like this one, manganese. It can make 3 different ions: a 2+ ion, a 3+ ion, and a 4+ ion. So all of the different elements that can make more than one type of ion is multivalent. So all of these ones are multivalent. These ones right here are not multivalent. They can only make one type of ion, as we can see here. This can only make a 3+ ion. This can only make a 7+ ion. Silver can only make a +1 ion. Zinc can only make a 2+ ion. And cadmium can only make a 2+ ion. So these ones are multivalent, and these ones are not. These are single-valent. So when naming, it's very, very important to check if something is multivalent or if it is single-valent. Let's take a look at some multivalent naming questions. So here's two questions. It says write the formula for these two. chromium, and then it says 3 in Roman numerals, oxide, and lead 2 oxide. So how do we write the formula for these? Well, there are 3 steps. Identify the charge, and the second step is the charge of the multivalent is written in the Roman numerals. And 3, balance the charge of the positive and negative ions, just like before. So, let's take this question right here. Chromium 3 oxide. Here's chromium, here's oxygen. Now, we don't know which chromium is being used. We do know what oxygen is going to be used because there's only one. Now, how we tell which chromium is going to be used, it's quite easy. It tells us right here in Roman numerals. So this number means 3. So what ion is being used? It is the 3 ion, or the 3 plus ion. So we can write that right here. Writing our formula again, we can use our crossing rule. This becomes a 2, and this becomes a 3. So our formula is Cr2O3. Now let's take a look at lead. Again, we do not know which ion is being used for lead. There are 2 of them here. But it says 2 right here. So we know that the 2 plus ion is used. So we can write that here. So when we rewrite our formula, we can write these numbers. Pb2O2. But these have a common denominator of 2. So what we can write is, instead, PbO. And this one right here is our final answer. These do not have a common denominator. Let's take a look at how to write the name. So writing the name of the formula has 4 steps. Identifying the metal, check to see if the metal is multivalent, determine the charge of the metal, and then write the name of the compound and place a Roman numeral to show the ion charge of the metal. So what we see here is we have Cu3N. On our periodic table, we have to find Cu, and we did. It's copper. And we also have to find nitrogen. So we've done step 1. We've identified the metal's name, copper. Check to see if it's multivalent. It makes 2 different ions, so it is multivalent. Determine the charge of the metal. So what we see here is that we have N is a -3 charge. And therefore that equals -3. Now what we can see is that we have 3 coppers. We know that these 3 coppers have to equal +3. So if they were 2, using this ion right here, (2, 4, 6), this does not equal 3. So it is not this one. It must be Cu plus. Because that does equal 3. So this is not the ion that we use. This is the ion we use. Cu1 plus. Because that gives us a total charge of 0. So what we're going to do now is we're going to name this by writing the metal first. Copper. The ion that we used. We did not use this ion. We used this ion. So we're going to write 1 in Roman numerals. Copper 1, then we write nitrogen. However, what we have to do is we have to remove the suffix and replace it with IDE. Instead of nitrogen, it becomes nitride. And that's our final answer. Copper 1 nitride. Now, for the next one right here, we have PtS2. On our periodic table, we can find Pt, and we can find S, sulfur. Step 1, identify the metal's name. Platinum. Now, we can also find sulfur, S. It has a charge of 2 minus. There are 2 sulfurs, S2. So we know that it is 2 sulfurs like this. The total charge of these 2 sulfurs combined is minus 4. Platinum, we have 2 choices, 4 plus or 2 plus. We only have 1 platinum here. If we choose 2 plus, then this equals positive 2, and therefore our total charge doesn't equal 0. So the charge must be 4 plus right here. Because then that means the charge of platinum is positive 4, and our net charge, minus 4 plus 4, is equal to 0. So the ion that is used is this one right here, 4 plus. So we're going to write the Roman numeral 4, which is 1, or I, and then V. And then we replace sulfur in here. But we have to remove the suffix and replace it with IDE. So sulfur becomes sulfide. And these are our final answers. Platinum 4 sulfide, copper 1 nitride.